Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show, bringing you another fascinating guest today who is helping to create a better tomorrow for many people out there. Today we have the honor of being joined by Dr. Gaurav Bansal, who is Senior Manager of Computer Vision and Machine Learning at Blue River Technology, which is a company of innovators that is focused on driving radical change in agriculture, ultimately by creating intelligent machinery to empower their customers, namely farmers, to implement more sustainable solutions, optimize chemical usage, reimagine routine processes, and ultimately improve farming yields. Blue River was acquired by the John Deere Company, is now a wholly owned subsidiary of John Deere, the American manufacturer of agricultural machinery and heavy equipment, forestry machinery. Dr. Bansal has an undergraduate degree from the Indian Institute of Technology in electrical engineering, his PhD in Statistical Signal Processing, Optimization, and Machine Learning from the University of British Columbia. He's been with Blue River for about 2.5 years. Prior to Blue River, he has spent time as a researcher at numerous organizations doing a lot of really cool stuff. He was at Acubed, the Silicon Valley Innovation Center of Airbus, focusing on things like autonomous flight, machine learning. He was at Toyota, working on areas like dynamic vehicle and pedestrian detection, brake and gas pedal status, connectivity, positioning. Also worked at Mercedes-Benz R&D. Has been involved in a lot of really exciting things. We're going to really be excited about hearing what he's doing at Blue River and Deere. Dr. Gaurav Bansal, thank you so much for taking the time to come on our show today.
Yeah, no, thanks, Ira, for having me. I'm super excited for talking with you and share some of the work that we're doing at Blue River.
Excellent. Yeah, I mean, I'd love to start off like we typically do by really handing you the floor for a little bit, just to talk a little more about yourself and get to know you a little bit. If you could sort of take us into the early journey so we could hear about everything from where you grew up, when you developed your interest in STEM, electrical engineering, obviously machine learning, AI, and a little bit of that early career journey and how you got involved in some of these really bleeding edge areas of research. I think that'd be a great way to get started.
Yeah, no, awesome. So I grew up in a really small town in northwest of India, and so I sometimes tell my friends here in the US, you can think of the town that I grew up, Bharatpur, as like Akron, Ohio of India. And like when I grew up, for example, we don't have a swimming pool in the whole city, so I don't know how to swim because I didn't grow up.
I actually spent a lot of time in Akron in a previous career, but we'll talk about that after the show.
Yeah, no, it sounds good. And so I also grew up, like my dad is a doctor, and some of my like aunts and uncles. So I grew up watching him being in STEM, and I remember, like when I was in like high school, this is where in India, when you grow up, you kind of decide like what kind of, whether you want to go in STEM or do you want to go into any other fields. And I had like a part of me always wanted to be a doctor, like seeing my dad doing it for all of his life. But then I was much better in math than I was in bio. So I always knew I wanted to be in STEM. That's kind of that's what my fascination was since I was like a small kid, and so that kind of led me to go into engineering, and I did my bachelor's from IIT Kanpur. It's in another small town in a different state in India, like kind of 6 hours drive from where I grew up. And while I was there, so I started. I did my bachelor's in electrical engineering, but and I was fascinated by that was back in like 2001 to 2005. I was fascinated the things that technologies could enable, and at that time, especially, I was looking into connectivity using signal processing. Cell phone was kind of a new idea. iPhone was not yet there. And that kind of led me to, I was really interested in pursuing higher studies. I went and did an internship in Germany. That was my first time outside India. Like, I think the first guy in my family who ever took a flight back in 2004. But all that led me to come to Canada for my PhD. And from there, I came to the Bay Area to do my internship at Mercedes-Benz. That was back in 2007, 2008, before anybody was really talking about self-driving cars. There was no Google X working on it, and the problems that we were working at Mercedes was to solve traffic accidents. Like currently, around 100 people die every day in US in car-related crashes. Most of them happens on intersection, like 48% of them, because people, especially in kind of suburban or rural areas, they're running stop signs. Because you're on that stop sign every day, there's nobody else coming, but except that one day. So we built this technology where before any machine learning, computer vision era, where we allowed cars to share sensor data among each other, and then you can give a warning to the human driver that there's somebody else coming, from the perpendicular side of the street. And so all that kind of led me to really focused on vehicles and how can you really work on technology for change. And that led me to go to Toyota. I worked on self-driving cars for almost 7+ years. Deep learning game, especially working on perception, how you could use computer vision to really build a vehicle that could drive on its own. That really motivated me, and it could solve like lots of problems that exist in the world. But few years into it, which I think the industry is realizing that self-driving cars, it would also be a tremendously useful problem, useful problem to solve. But technology might not be completely there, because the problem in cars is much more difficult. There could be hundreds of pedestrians when you are in Manhattan downtown, for example.
Sure.
And then that led me to go and work in planes. That maybe because when you're flying planes, you don't have people in the sky, and the perception problem is much more tractable. So I worked at Acubed Labs, where I worked on this team where we landed the first plane using neural networks out in Toulouse. And kind of year and a half into it, it was a really cool technological problem to work. How to automate the plane, and if you go and talk to companies like Airbus and Boeing, one of the reasons they can't scale is because it's very hard to find pilots. Apparently, only 20% or so of the world has ever been in a flight. Almost 80% of the world has never been in a flight, and the challenge is not being able to have pilots. And we were trying to solve that problem by automating it. But soon I realized one of the challenges there is the regulation is super heavy. FAA currently does not allow any software in the plane that is not traceable. And all that kind of led to my current journey, where I met good folks at Blue River around 2.5 years. And they shared with me this problem on autonomous tractor, and especially kind of what really motivated me to come here is the impact that this technology brings to solving the current problems that farmers face. Currently, farmers and if you look at the stats, in next 30 years, the world's population is going to grow from 8 billion to 10 billion, and that means we have to increase the food production by 50%. But it's really hard to find labor in the rural area.
Yeah.
And so that's there's a need for it today that our customers have. A second important piece of it is the technology is ready for doing autonomous tractor, because the environment that you're operating in is very different, and all that kind of led me to come to where I am, and kind of start working at Blue River and John Deere.
Outstanding. Yeah, but no, it's a very exciting journey just listening to you, and I definitely see all the issues and the solutions that ultimately come out of what you've learned so far in terms of AI and these tools for the farming domain. Before we get into it, I'd like to just take a step back for a moment and talk, if you would, a little bit about computer vision. Because we talked a lot about AI on the show as this sort of amazing tool, very hot topic nowadays in terms of we got all this data, we need this fascinating tool of AI, machine learning to really get into it, see these trends, understand what's going on in it. Computer vision seems like a AI plus, where you're really training these computers to interpret, to understand what they're seeing out there. Take us through a little bit about sort of where computer vision is nowadays, sort of in the AI ecosystem, if you would.
Yeah, so I think so. Vision is one of the fields where machine learning is starting to work really well. Okay. And so when we're trying to do computer vision, typically there are two main problems, especially from autonomous driving perspective, that you're trying to solve. One is you want to know what is in the image. Like you have this two-dimensional image. Is there a human in the image? Is it ground? Is it trees? Is it sky? That's the first problem you're trying to solve. The second problem that you're trying to solve is, where is it in the real world? So as humans, we can not only see, there is this human in front of me, but we also have a pretty good idea on how far this human is from me. And we use that to navigate around objects and that we see around us. So that is the second problem, which in the community we call as depth estimation. That just by using images, you want to know how far things are. And so before deep learning, people used to use like what we now call like classical approaches. They were based on heuristics, and kind of back in like starting from like early 2000s. People also started using machine learning, but these were not neural network-based approaches. These were like machine learning algorithms like support vector machines or logistic regression. And you will start seeing that now you can detect things, both the problems of detection and depth estimation, they started to work better. Like you can, but it was nowhere close to where you want it to be. So 90% of the time in a pre-deep learning era, you could be able to detect, oh, there is a human in my image, right? And you can say, oh, this is where in the real world, but I could say it with 20% error, which is better than not predicting it, but 20% was still not good enough for enabling products and especially robotics. But then really what happened after deep learning, which kind of had a rebirth from this AlexNet paper that came out in 2012. And as we have worked in our solution in our autonomous tractor, so we've heavily relied on deep learning for solving the vision problem. So last 3+ years with as Deere, we have been in like more than 20+ states. We have collected like hundreds of millions of images, and for making machine learning really work for vision, what you have to do is you really want a lot of diversity in your data. So you don't want just it from one field or one grower or one state. You want it from many states, hundreds of growers, hundreds to thousands of fields. This is one geographical diversity that we use. Second aspect that we use is we have built a solution that it works 24 hours. This is how we increase the productivity for our customers in solving this vision problem. So you have to really collect data, images, not just in the daytime, but also in the dawn time and in the dusk time and in the night time. And then let's say if you're trying to solve for human detection, then you want to have very good diversity of humans. That means various heights, various weights, various clothing that people could wear, several poses that they could do. Like internally we say that if you want autonomous driving work with vision, you have to really solve for being able to detect laying down humans. This is because that's a rare thing, but it still could happen. And as humans, we are able to detect if some person is laying down on the ground. And that's how you solve this. That's how you kind of combine, or that's how you leverage machine learning to make it work for vision. You go and write all your scenarios, you go and collect that data, and then you use smart techniques to train your machine learning, deep learning models for it.
Excellent. And, Gaurav, you mentioned a little bit before, you introduced us to some of the sort of major issues that we have nowadays. We have a growing population on this planet. We need a lot of food. I joke that, I profiled some interesting food tech on the show in the past, but it's not going to feed 10 billion people yet. And then also, as you were saying before, this issue that we don't have a lot of farmers anymore. They're aging. People aren't getting into the agricultural workforce. Introduce us at this point to the concept of precision agriculture, because in sort of reading sort of the general definition of it, it's not just, hey, we're going to plant the wheat here and the corn over here. There's a lot of also intra and interfield variability in soils and all sorts of different things that happen in the ecosystem that is a farm. Talk a little bit about what precision agriculture really means at Blue River and Beer.
Yeah, so precision agriculture really means using like a controlled method of doing farming in a way that we can get the most production out of our crops. Like in many ways, it's about taking individual care of crops. And I'll give you an example that See and Spray. This is something that the Deer and Blue River have been working on for past few years. This is a really good example of precision agriculture. So in See and Spray, what we do is, currently when farmers spray the crops, only 20% of what they are spraying is on weed. Remaining 80% is either on ground and crop.
Got it.
And what we do with precision agriculture is that we allow we put on the sprayer, we put cameras and running neural networks with GPUs that are mounted on the sprayer. We're taking real time images and then finding out whether there's a weed or not. And these are decisions that are taken like really, really fast, like in orders of tens of milliseconds. And only the part that has weed gets the spray, and otherwise it does not. And what it leads to is, it's more sustainable because all the spray eventually ends up in the in the rivers. It also leads to healthy crop because you're only spraying your herbicide on the weed and you're not spraying it on the crop. And it also helps in the bottom line of our customers because herbicide is one of the costs that they have to pay. This is like I think the second or the third largest cost for the farmers.
Sure.
So precision agriculture is all about doing agriculture in a way that we can get more out of less. And it really goes into the heart of this problem that we talked about, that we have to grow the production by more than 50% in next 30 years. The farmers really have a big labor shortage, especially for doing things like individual crop care. Like in next 10 years, the labor on the farms is expected to grow by only 1%. As opposed to growing the production by 50% in next 30 years. And this is why we heavily rely on technologies like big data using information technology, then sensors, automation, geospatial intelligence, because all that allows you to allows farmers to make decisions based on whatever the individual part or whatever the parts of the farm need.
And so, I mean, it's incredible work, incredible science, and it seems like the culmination of a lot of what you've been working on, just recently unveiled this year at the Consumer Technology Association Expo, the autonomous 8R tractor, fully autonomous, and I'll let you go into, has the amount of cameras and sensors and so forth that this has is just amazing. I like the cool little part of the ad where there's the farmer controlling with their cell phone, and you can focus on other things, and there's the connection, of course, to the John Deere Operations Center, which kind of reminds me of the way the airplane engines are now connected to groups all around the world. Talk a little bit, or take some time actually, if you would, because it's a fascinating piece of equipment. Talk about the 8R tractor, and then obviously you mentioned some of the things you had to think about in terms of self-driving cars and self-flying airplanes. Take us through a couple other interesting stories about things that you had to work out as you were creating this amazing device.
Yeah, definitely. So our autonomous 8R tractor that we unveiled at CES this year, it's a vision solution. The perception system is based on a vision sensor. So we have put 6 stereo cameras, 3 in the front, 2 on the side, and 1 on the rear. They build a safety bubble around the tractor. And so the way stereo cameras work is very similar to human eye. Like in human eye, we are able to use 2 eyes. As I was telling you earlier, that as humans, we not only know where the object is, but we can also know how far it is. And this is why we use stereo cameras for being able to detect and know how far things are. In order to solve the detection problem, so building the safety bubble and really knowing what is in the image, we train over hundreds of thousands of images that we collected in last 3+ years. And kind of another big innovation that we have done at Deere in building this is, so we actually divided the world for our neural networks in 5 categories. Which is drivable terrain, what the autonomous tractor can drive on; sky, which is always infinity away; trees, that typically tend to be on the horizon or on the headlands. Then the 4th class is the large object class. Everything that we should stop for when they are within our safety parameter, which includes obviously humans, animals, buildings, vehicles, trash cans, any object except the implement. Because when we are in tractor, we are always trying to do a job, and we have started with tillage for this first tractor that we are rolling out. So we stop for every large object when it crosses in our safety bubble, except the implement. So this is what our neural network does. It is a model that takes RGB. This is the red, green, blue component of the image, and the depth that is coming from the stereo camera. It takes it as an input. It goes through this neural network, which is millions of parameters, and it gives an output for every pixel that it belongs to one of these 5 categories: ground, sky, trees, large objects, and implement. And the way our system works is, so we have this safety bubble, which is 10 meter, in front of the tractor, because tractor goes only for tillage only 6 to 8 miles an hour. If we see any large object within our safety bubble, we stop the tractor. And after that, what we do is we send these images to the cloud, where we have 3 independent humans look at those images. Because sometimes, it's very rare, but it could happen that tractor stops for a false positive. Because machine learning model that we have designed, it's very safe. So sometimes it might think of a shadow, that maybe there is a small chance that there is an object there. So we stop the tractor, then these images go into the cloud. We have 3 independent humans look at it. And if all 3 of them say it's a false positive, then we restart the tractor. All of this process happens in less than 30 seconds. But if it is a true positive, then we send a notification to the farmer. And then farmer, as you were saying, farmer is always constantly connected to the tractor from their iPhone app. Always they could see, what the tractor is seeing. In this case, we send this notification to the farmer, and they can decide. They would have an option to nav around the obstacle, like, if it's a large rock or if it's a trash can, or they would have an option to come in the field and move the obstacle. So that's how we have designed the system, and it's designed to work 24 hours. And this is also one of the key differences, that some of the I like to call them superhuman farmers, especially during peak season like harvest. It's very common to hear stories where they work 16-hour days. But using this tractor, which we can run autonomous tractor 24 hours, we can increase the productivity by more than 30% for them.
Excellent. Excellent. That's it's completely fascinating. It's definitely night and day between where we've been. Talk a little bit, if you would, about, obviously Blue River is now part of John Deere. It's one of the major companies on the Fortune 500, and we talk to large companies on the show. We also talk to a lot of the younger startup innovators, the university labs that are working on cutting edge tools. A lot of people in the AI space. Talk a little bit about how your organization works sort of with external innovators. Obviously, you've worked on this, spent a lot of time, but you got a lot more going on. What are some of the things you're looking for from startup innovators in terms of startup companies, in terms of university labs? What types of research are you particularly interested in looking out, potentially funding or partnering with in the ag tech space? Take us a little in that journey, if you will.
So actually in 2019, Deere launched a startup collaborator program,
okay.
and that allows Deere to select startup companies and test innovative technologies with our customers and dealers. As John Deere, we have been doing it for now 3+ years. One of the recent startup that Deere acquired was Bear Flag Robotics. It's a Silicon Valley company, also working on autonomous driving tech, which is compatible with existing machines. And it's even though Bear Flag's autonomous technology is separate from Deere's autonomous tractor, but this will help us in our collective goal of creating advanced ed tech for our farmers. And so I think as John Deere, this is like one big avenue for us for being able to work with innovators and people in STEM, people who are working in ed tech, to see how they could solve problems for our customers, and how we can participate and collaborate with them even in early stages through this collaborator program. And kind of touching on the piece around university relations as well, I think we are interested in partnering with universities in solving some of the research problems that are out there, right? As an industry, we have to especially like the technology is moving so fast in machine learning space, computer vision, big data, and there are some problems which are really innovative problems. There's maybe 50% chance that they might not work because they're still in research domain. That's where kind of we really prefer to partner with universities. We have done some of that in Blue River and as John Deere, and we plan to continue to do that the same as we kind of grow from here.
And in the intro, I mentioned that you came through the path initially of electrical engineering, and then you got into the machine learning space. Actually, we have some of the next generation that is going to be listening to the show. Talk just a little bit about sort of what you're looking at in terms of sort of recommending to that next generation that's coming along. Is it an electrical engineering path? Are there technologies that you think about nowadays? Wow, we should probably be studying, whether it's quantum computing or edge computing or some of these other disciplines that are over my head. And then a little message about why, amongst all the tech, why ag tech is a hot space that the next generation of STEM innovators should be interested in, and along with all the other tech we talk about on the show.
Yeah, no, I love this question. So kind of starting with the first part, I think some of the technologies that are personally really interesting for me and I believe have a lot of potential in next 10, 20, 30 years. Obviously, computer science is now this kind of a big discipline, being able to code and being able to really write software that is scalable, that is fault tolerant. But on top of this, technologies like robotics, machine learning, computer vision, also other sensing technologies like radars, geospatial intelligence, all of those, and how you could really leverage big data, in designing more and more intelligent systems? How do you leverage your skills and expertise in mathematics, software, and problem solving in building products that are going to have a huge impact in society moving forward? And my the pitch for EdTech is, so we are really building a tech for change, as I kind of stated earlier as well. So for farmers, they have to increase their production by 50% in next 30 years.
Yep.
But another kind of very interesting stat is that only 3% of the land in US is urban, but 80% of the population lives in the urban areas.
Mm.
And if you go and talk to any farmer, being able to recruit and find labor, that is like one of their main problems that they have. And as we are growing, we have to grow this, the production that farmers have to produce, because they need to create these crops in order to feed the world, fuel the world, and clothe the world. And so if you build in this space, you're actually going to have a real world impact, because you're going to solve the real world problems that we have. And my last thing I would say here is that with EdTech, we also have a really good product market fit. The technology that exists today is really ready for building these solutions and start deploying it for farmers. So that is like in some of the technologies, it could happen that things are out there, but in EdTech, we are doing it today. So that's kind of another good reason for people who are coming out of STEM today to come and explore EdTech.
Yeah, that is definitely an exciting point that you can see, as in the case of the ADAR, that you see this translation. I come out of the pharma space, and it could take 20 years for us to see anything get to market. But that's this is the really exciting piece of the puzzle as well. So that I'm glad you made that point. Well, one other question I have for you. Obviously, I love listening to our guests on the show, but I also love hearing about our guests' mentors. And obviously, you've had an amazing career. You spent time in academia. You've spent time at some of the largest organizations in the world, the largest corporations, doing research in some of these cutting edge areas. Take a couple of minutes, if you would, just to talk about some of the mentors, the influencers that have been there along with you, that have inspired you, kept you on this path on those days where you said, I don't want to do this anymore. I've kept you on the straight and narrow and been there with you.
Yeah, no, I'll love to quickly share. So for me personally, like one of my biggest mentors has been my mom. So my mom grew up in a even smaller town that I grew up in. She grew up in a village, and that was back in '60s. Like her dad was a famous lawyer in this village, but he also had this thing that he didn't want his daughters to go to college. Like he just wanted them to just study until high school. And then my mom, she knew this. She really wanted to go to college. So where I grew up in my state, there is an exam that you take, which is a statewide exam. It's not, even though you might be living in a small village, but the whole state, like California, takes this test. That was the last thing she was going to study. So she worked so hard for it that she got the second rank in the state. And her dad found out while he was in court. And that was the reason he sent her to college. Otherwise, he would not have sent her to college. So she has like really inspired me over the years to kind of just suck it up, work hard, and do what needs to be done. So she has obviously been a big mentor for me. But along the road, when I was in my undergraduate college, this professor that I had, Professor Ajit Chaturvedi, he really taught me that when you're trying to do science and engineering, what is really important is fundamentals. A lot of people are really stuck in or like spending a lot of time in thinking about high level details, which are important. But when you're doing science, what is really, really important is that you get your fundamentals right. And then you can kind of go and build your fort on top of it. If you don't get the fundamentals, don't go towards high level details. I really learned that from him, and that kind of has really helped me. And now when I started working in the Bay Area, I had this mentor at Toyota, a guy named Roger Mellon. He was a professor at Stanford, and he also had his startup in semiconductors. And he really taught me a lot about the industry, about the tech industry, like how there's so much work going on, but some of it is really going to matter, and some of it won't. So how do you especially like bring your tech to things that's going to have an impact in the world? How do you evaluate that? How do you bring your skill set to things that can actually change the world? So I learned a lot of that from Roger. And then the last person that I would mention is actually my current boss, Willie Pell. And I've been working with him for 2.5 years. And what I've really learned from Willie is that people are really important when especially when you're working in an organization and you're trying to really deploy a product. It's all about the people. People have numerous they have unlimited potential, and really working well with people is an important part of being successful and delivering something that's going to be useful.
Outstanding message. Really great message. Gaurav, it's a fascinating story, and your journey is amazing. I'm going to be continuing to root you on, not just in the translation of what you're doing now with the 8R, but it'll be exciting to see what comes next out of your organization. For everybody that is going to be listening to this particular episode across the podcast networks or watching on the YouTube channel. You've been spending time with Dr. Gaurav Bansal, Senior Manager of Computer Vision and Machine Learning at Blue River Technology, subsidiary of the John Deere Corporation, doing really amazing things to drive radical change in agriculture, empowering farmers to feed and fuel the world efficiently, sustainably. Gaurav, I want to thank you for taking the time out of your schedule to come talk to us for a little while. Obviously, thank you for everything you're doing there at Blue River. And as we like to say on this show, thanks for helping to create a better tomorrow through what you're doing and designing. Really fascinating story.
No, thanks, Ira, for having me. I love talking to you today and your audience. And if you are up for getting a ride on our autonomous tractor, let us know. We'll be happy to host you in any of our facilities in like Iowa or in California.
I'll take you up on that one day. Absolutely. Be well.
Cool.